Pick it up now. I don't really see it anymore, but you could see flames sort of shooting out every so often. I don't see it anymore, but you could see flames sort of shooting out every so often, and they looked like they were flames produced by welding machines. Obviously, they're trying to
And then I looked at those with electron microscope using elemental analysis called X-ray energy dispersive spectroscopy. And there we found that there was a lot of iron in these spheres. And I realized that a magnet then could pull these iron-rich spheres out of the dust so we could look at more of them. I remember Dr. Fair of BYU and I looked at this sample together.
I like to do this in a fume hood just because it's fairly uncluttered, and also who knows what's in this dust. Yeah, I'm not real impressed with this magnet, but I mean the looks of it. It happens to be a very strong magnet, and invariably you pick up all the other junk along with the magnetic materials. So that's why you have to sort of visually go through it with tweezers and inspect it and pick out and manually pick out the particles with tweezers.
Using a magnet, we're able to find very large numbers of these spheres. Some you can see with your naked eye, and more you can see with the optical microscope, and then many, many more you can see with the electron microscope. And many of these are aluminum and iron together in the sphere. A very unusual combination. The only way I've been able to duplicate that particular combination is with thermite. The essence of thermite is a reaction between aluminum metal and iron oxide, very finely ground. And when they react, you get aluminum oxide and iron, molten iron, but sometimes the aluminum oxide will get trapped with the iron. And of course, it's hot enough that these are molten, so as it sprays into the air, you get droplets. And these will contain iron, and aluminum will be caught in there too. And that's just what we see in these spheres, a lot of them, matching what we get from the thermitic reaction. And then we looked a little further at the dust, and I noticed there's also another type of particle in there. And this is what I call a red-gray chip. I started looking at the chips because they were distinctive. Red on one side, gray on the other.
Okay, so I'm looking mostly for the red chips, because the red chips we find to be most interesting as far as the chemistry and also in the calorimeter. It's sort of, you know, looking for a needle in a haystack almost, because there's so much dust. This is kind of hard because you're going through this thing. You can't really tell where your tweezers are. And that's about as big as we're going to get. So in terms of millimeters, that the red chip is about it's close to 1 millimeter long, but it's maybe 1/4 millimeter wide. The way that I first heard about this issue from Steve, I actually read his paper in 2005. Even after reading the paper, it took a few days to sort of absorb it and really let it sink in and get over some of the, what would you call it, the implications of what that paper was saying. Once I was able to get over those implications and sort of say, okay, forget the implications for now and just look at the science. And once I did that, I started saying, okay, there are a lot of questions that need to be addressed. And then I actually met Steve Jones on campus, and I told him, I said, look, if you would like a collaborator, or if you would like me to help with some work, I told him what my skills were. I told him the type of facilities that we had in the lab, and of course, him being at BYU, he would have full access to those facilities. So that's how we got started.
Initially, when I saw these red-gray chips, I looked at them just because they were unusual. I didn't have any guess as to what they might be.
He told me about the red-gray chips, and I was mildly interested in the red-gray chips. I didn't think anything of them. But the number that he was finding of these red chips made me think that perhaps they were significant.
And then I explored the nature of these chips using the electron microscope system, and sure enough, they contain the thermitic material, namely iron oxide, aluminum, and silicon and carbon are quite common. In fact, the fine grain of it is so fine that I would call this a nano-thermite material.
At some point, we were talking about these chips, and at some point I suggested, look, if these chips really are of an explosive nature or an incendiary of some type, then all it would take would be to put one of these things in a calorimeter and see what kind of energy we got out as we heated them up. I know they're energetic, so there's no question about that. I mean, the calorimeter's not going to lie to us.
As my materials scientist friend said, they blow up. We found that the energy release is very rapid, so it gives you a very narrow spike in the machine. We compared our spike that we got with a spike from known nano-thermite, which is produced at a military laboratory. Their measured energy released with known nano-thermite was less than these red-gray chips. We captured the residue after the material had been heated. The red-gray chips, as we ignite them, produce spheres that have iron and aluminum, just like we see in the dust in abundance. So now we have an explanation, or at least a correspondence, from what we see in the dust after the reaction of the red chips and before. So, I mean, everything just click, click, click fit together. It's very exciting, really, from a scientific point of view.
When you put all that data together, then you obviously can draw your own conclusions, but the conclusion that we drew, which I think is a very good one, is that these chips are energetic. I mean, these chips have something to do, I mean, they're like an incendiary.
This pyrotechnic explosive material should not be in the World Trade Center dust, particularly in these large quantities. I mean, there are people in these buildings. What are these tons of explosives doing in there? Unless somebody really wanted those buildings to come down completely.
Steve didn't know what he was looking for when he first started looking through the dust. And we didn't know what we were looking for. We didn't know what we would find. You know, we're doing this on a shoestring, and I mean, we're being supported exclusively by private individuals. We did what we could with what we had. Obviously, you can always question that, and all the stuff that we've done can be reproduced. I was a little bit surprised and disappointed that there weren't more people that wanted to try to reproduce the work.
It's kind of funny, these guys sit back and sort of take pot shots, but we're the ones doing the experiments. We're in the lab. You know, we're doing the tests. And we're finding out that there's a lot more to 9/11 than just Al-Qaeda hijackers hitting the buildings.
I'm not trying to blame anybody or accuse anybody of anything. I just think that we need to continue looking at this. I don't think it's done. I don't think we've answered all the questions. I know we haven't answered all the questions because people are still asking them. And those that were part of the official investigation, they actually did what they said they were going to do. And they did what they were mandated to do. The problem is the mandate didn't go far enough. It needed to run the full, the full investigation, find out everything about what happened that day. Everything. Not just, okay, tell us how these buildings could have possibly collapsed. And don't look at anything else.